BMED 2210 is a course in the BME curriculum that focuses on conservation principles in BME. It is a study of material and energy balances applied to problems in biomedical engineering. This class requires a specific process of comprehending a problem, drawing a diagram or diagrams, making relevant assumptions, setting up a system of equations, and computing the answer.
So for this problem, we're given a diagram of the trachea and main bronchi in the respiratory pathway. We're told that air inhaled through the nostrils travels down the trachea before splitting into the two main bronchi. So here's our left and here's our right, which then split into several generations of bronchi, which then become bronchioles, and the path of airflow terminates at air sacs called alveoli at the ends of the bronchioles. The problem says, suppose a person inhales 0.5 liters of air in an average breath over a period of 2 seconds. So we can write V for volume equals 0.5 liters, and T for time is the span of 2 seconds. Write a mass conservation equation for airflow through the trachea and main bronchi. What is the mass flow rate of air through the trachea? So actually, let's make a heading here. These are our knowns. And I'll make a separate one here for our unknowns. And we are to find the mass flow rate of air through the trachea. So mass flow rate trachea. There's one. Also, what are the velocities of air through the two main bronchi if the mass flow rate in each bronchus is assumed to be the same? So we're going to have two different velocities. Here's velocity of right and air velocity through the left. Assume the air does not humidify in the respiratory tract. The trachea has a diameter of approximately 2 centimeters. Trachea, diameter, 2 centimeters. We're also given that the right main bronchus is slightly larger than the left, with diameters of approximately 12 millimeters and 10 millimeters respectively. So our diameter of right was 12 millimeters, and our diameter of the left was 10 millimeters. The density of air at room temperature is 1.2 grams per liter. So here's our last known. Density of air at room temperature would be 1.2 grams per liter. So to solve this problem, we're going to switch to a simplified model. So here's the trachea and two bronchi, and we drew a system boundary around the parts we're concerned with, because we're only solving for mass flow rate of trachea, which is this part, and the air velocities through the right and the left. Here are our knowns written down here. So first, what we want to do is assume that the system during one inhaled breath is at steady state and non-reacting. So we can model the trachea and bronchi as cylindrical conduits. And since no humidification occurs, we assume that there's a constant air density. So because of this, we can use our conservation equation for mass flow rates. So the flow rate of mass in through the trachea minus the mass flow rate through the right bronchus minus through the left would be 0. And this makes sense because all the mass that comes in ends up having to go out somewhere.
So the next step, now that we know that the velocity of the air in the trachea is 79.6 centimeters per second, is to find the mass flow rate. So we can find that by multiplying the cross-sectional area by the velocity times the density of the air. And we know that the area is going to be 1/2 times 2 centimeters squared times pi. And the velocity is 79.6 centimeters per second. And we know that the density of air is 1.2 grams per liter. And with using a conversion factor, again, we can say that we can multiply it by 1 liter over 1,000 centimeters cubed. And multiplying these all together, we get 0.30 grams per second. Alright, so the next step is to find the velocity of the air in the right bronchus, and in order to do that, we're going to have to find the mass flow rate of the air in the right bronchus. And since the mass flow rate in the two bronchi are equal, we can just do 0.30 grams per second over 2 is equal to 0.15 grams per second. And the velocity of the air in the right bronchus is going to be equal to the mass flow rate over the area, which is going to be pi times d over 2 squared times the density of the air. That is going to be equal to 0.15 grams per second over pi times 1.2 centimeters over 2 squared times 1.2 grams per liter, and then multiply that by the conversion factor, 1,000 centimeters cubed per liter, and you get 111 centimeters per second. Now we can just do the same thing for the left bronchus by using the same formula. Since the mass flow rate is going to be the same, we can just replace the diameter of the thing with the diameter of the left bronchus. Left. So it's going to be 1.0 centimeters. And then that is going to end up being 159 centimeters per second.